Hello everyone. So in last lecture or in last lab we have seen that how we can set up our base station, and in today's lab we will see that how we can connect our base station with our rover station. So in last lab we have installed or we have set up our base station, and now we will connect the or we will establish the real time kinematics. So once your GPS receiver has been on, here you can see the battery information, the Bluetooth information, the card information and the signal information, and this signal, this arrow is showing that this receiver is been receiving signal from your base station. In our base station we have seen that this light was blinking, but on the this rover, this is the receiver, the rover receiver. So in your this receiving signal is blinking. So this means that it is receiving signal from your base station, or this GPS receiver is been working as a rover receiver. So if this signal is been blinking on your this rover receiver, so in that case you have to make it this GPS receiver as your rover station. Blinking of this light, that means this one is working as a base station, but you have to keep it this one as a rover station. So and this function button, you can simply change this change this base station as a rover station, so that you can change by using this function key. So once your GPS is on, or it is receiving signal from the base station, or it is working as a rover receiver, so then you have to connect this field controller with your GPS receiver. In this case it is not connected because this green light is been showing. Once it is connected with the field controller, the blue light you can see over the Bluetooth symbol. Now we will go to the field controller and we will see that how we can connect the field controller with the GPS rover. So this was our last setup. Here you can see the base setup completed, and now we have on our base rover and rover receiver, and then now we have to go to the rover. Here two options has been given. First is rover and the another is base station. You have to keep in mind this CQ, the quality coordinate quality. This coordinate quality is currently 4.9 meter. Although this receiver, rover receiver, has been receiving signal from your base station, but the RTK is not initialized yet. So you have to initialize RTK, or you have to make a communication between your base station and your rover station. To do that, you have to first connect this rover this field controller with your rover station. So you have to simply click on the rover. So it will show you that the connection with your base station has been lost, and now it will connect to the your so now you can see one information is pop up. The current sensor is operating as a base. Do you wish to operate as a rover, or you connect with the cable? Simply disconnect the cable. This information you can see over your screen, and you can click on the S option, and this will direct you to your rover menu. So this is your rover menu, and the Bluetooth symbol, you can see it is not connected yet. So if it is not connecting, so you have to go to the instrument and connections, all other connections, and here you have to change your Bluetooth ID. So to change your Bluetooth ID, you have to go to the edit option, and here you can see the last used rover was 959. This is the Bluetooth ID for the base station. So you can search this you can search Bluetooth options, and here you can see the Bluetooth ID for the rover receiver is 995. So we will connect with this receiver. So you click OK. You wait for some time, it will connect with your receiver, and here you can see the Bluetooth signal, and your satellite signal. So now it is connected, this field controller is connected with your rover station. So your rover station is receiving 15 satellite, and 14 to 9 satellite is been available to give you a precise locations on this globe. So to mark a position on the earth, at least 4 satellites you have to need to mark the precise position on the earth. But here you can see the available satellite which will provide you the correct latitude, longitude and elevation for your desired point. So here this menu you can see, this is your rover menu. But this 3 DCQ you can see still it is 6.5 meter. So this error is quite high. You have to minimize this error. You have to keep this GPS receiver in a place where this GPS receiver can receive signal very clearly. So you have to keep in mind certain things. You have to avoid the hindrance while receiving the signals from the vegetations or buildings. So you try to keep your receiver such a place where your receiver is available to receive maximum signals from the satellite. So in this case, this satellite, this RTK is not at initialize. So you have to put your this receiver in a open space. So we will little bit move this and we will see that where we can see a good signal from the satellite. Now here you can see the 3 DCQ, that is 0.033 meter. So this is the centimeter level accuracy which we have achieved while connecting your base station with the rover station. So in this scenario, your base station is also receiving signal from the satellites, and in a real time it is calculating the error associated with the with its position, and that error it is transferring to the rover station, and the rover station which is also getting signal from the satellite as well as the error correction from the base station, and that error correction it is doing, and on a real time it is giving you a precise location at a 37 to 30 centimeter level. So this is a high accuracy, high accurate locations. So now in this case we can see we can say that it is the RTK has been initialized, and you can your system or your setup is ready to collect the data. So with this accuracy level you can acquire the elevation data from your respective areas or your research areas. So now we will acquire some data, or we will show you that how with the using this these options you can do your survey. So in the go to the work option. So this options is on this option few surveying options are given. Here you can see the survey, stakeout, survey plus. So these are the different options are available for different kind of work. So for our purpose we will simply use this survey option, and with this survey option you would be able to acquire or collect the data. The another option is the job and data. On the job and data you can see all your data which you have collected, or from this menu you can also export your data. So here you can see you can also create a new job, you can view your data from the job properties. You would be able to choose the see the information regarding your job, or you can also shuffle different jobs which you have created on your controller. You can import data or you can also export data. And the another, the instrument portion. On this instrument portion you can see the GPS setting, RTK rover wizard, the satellite tracking. So here you can see the GLONASS. So currently it is receiving signal from the GLONASS as well as the GPS GPS satellites. Here you can see the antenna heights. So you can also here the rover antenna height is although it is 1.8, you can change this antenna height while you are doing the your survey. So that we will see in few minutes. So from the go to the work option, here when you will go to the survey option. So on the with this survey option you can start your survey. So here you have to assign the point ID and antenna height. So the antenna height, that I already told you that it is set on it is set to 1.8 meter. So you can change this antenna height. So this antenna height you can change from this pole. So this on this pole it is written the height. So you can change this antenna height by using this lever. So here one lever has been given on your pole. So you can press this lever, or you can increase or decrease your height. So we will keep it at 1.8 meter. So that information you have to put over here, antenna height, and you can see the 3D CQ, that is your 3-dimension coordinate quality in the horizontal and vertical direction. So when this is at the minimum, you can do your measurement. So this is the survey panel, and with the help of the survey panel you can acquire your data, or you can collect your data. So if I want to collect the data for this point, so to collect the data you have to first give the point ID. You can by default it is GPS 001, you can keep it, or when you will click on the measure. So here you can see one options you can see on your screen, that is the RTK position. So that RTK positions it is increasing continuously. So right now it is 20. So when it is increasing, you can see your 3 CQ is going to minimum. So at the minimum level you have to acquire your data. So it is right now 23 centimeter. So at the 23 centimeter you would be able to receive your collect your point data. So when it is minimum, you can click on stop, and this information you can see the point GPS 001 has been stored in your job, in which you the job which you have created, the lab RTK1. So similarly you can collect the multiple point. The another way to collect the point is in this was the manual mode. The another way is the automatic mode. So you can assign some parameter to the system, and that parameter the system will automatically collect the point based on the parameter which you have assigned. To do that, you simply go to click the function option with the help of your remote controller, and you click on the configuration. Once you will go to the configuration option, here you can see the log auto point is enabled. So you can enable or disable this by clicking on the log auto point. So once you enable, now you have to assign some information, the stored point by time, whether you want to collect the point or data in a time mode or distance mode. So in time mode you have to give the log every time. So that you have to tell the instrument that you at what time or what interval you want to collect data for your survey. You can choose the time from 1 second to 10 second, or you can manually put your or you can manually choose your time from the drop down menu. Up to 60 second you can collect. So this means when you set your the automatic point collection with the time mode. So suppose I choose this for 2 seconds. So in every 2 seconds your system will automatically collect the point. Doesn't matter if you are removing your rover station or not, it will automatically collect the point. The another option is the distance mode. So in distance mode you have to give the distance at what meter you want to collect the data. For example, it is written over here, the 0.5 means the 50 centimeter. So in suppose if I give it a 1 meter, so in every 1 meter it will collect data. So if suppose I set up, and now you go to the auto option, here you can see you change your point ID. Suppose I assign it 001. So and now you click start. So you can see it is not storing the data, because I am not removing the my rover station. So when I will remove and I will cover to 1 meter, in that case it will store the data, because we have set the parameter to distance mode and at a 1 meter distance. So you can see if I remove my rover station and I go, as soon as I go to the 1 meter distance, or I reach to the 1 meter distance, so now you can see over here your point has been stored, because we have covered 1 meter. If you move further, so it will collect data at every 1 meter, and when it is collecting data, one beep sound you can hear from your instrument. So with this distance mode, you can collect data automatically while giving the parameter at what parameter you want to collect the data. The another mode which I was telling you, the time mode. So suppose I choose the time, and if I choose it as 2 second, so you click, and now you can see, you can hear the beep sound. Now here you can see, or it is continuously increasing the point ID. That means I am not removing my GPS rover station, but it is still receiving or it is collecting the information from this point only, because we have gave the input parameter as a time and in 2 seconds. So in every 2 seconds our system is acquiring data. The another mode which I was explaining initially, that was the manual mode. In the manual, the data which you are collecting in manual mode, that would be more accurate, because here on your so in automatic mode or in manual mode, one thing you keep in mind, that you have to keep or place this pole at a straight position, that you can see on your list labeler. One labeler has been also given on the pole, and you try to keep this bubble at the center, because that will give you a precise precise information for this point in terms of latitude, longitude and elevation. So you try to keep this bubble at the center. So once you completed all this part, now you can start survey, or whether you want to do it in manual mode or you want to do it in automatic mode. So now we will show you, we will keep one profile in manual mode, and then we will collect some point in the automatic mode. So we will start with the manual mode, and in manual mode you have to manually acquire data by pressing on the stored option. So you first go to the survey mode, and this is your manual mode, and this one is automatic mode. And the another option you can see over here, this is your map mode, and in map you can see all the information which you have collected for your region. Here you can see these are the point which we have collected right now. When as much as we are collecting more point, you can see all the information on your map. So we will do the survey, we will keep it as a manual mode, and it is right now in the GPS 002. So we will start with this default number, and we will collect some points in manual mode. In manual mode, you try to fix your bubble at the center, and then you can see this 3CQ is 0.022 meter. It is quite enough for our purpose, and we will click on the measure, and once we click on the measure, you can see, or you can wait for the RTK positions. Once it is minimum, you click on the stop option. So we have collected the another point at this position. So we will collect few more points in manual mode, and suppose we want to take the another point over these positions. So similarly you have to see your coordinate quality, that is 0.020 meter. You click on the measure, you wait for the RTK positions, and once it is minimum you click you click stop, and now you can see the sounds point stored. That means your point has been stored in your job. So here you can again click another point, you wait for the RTK positions and you click stop. So we have collected 4 to 5 point in manual mode, and now we will collect few more point in automatic mode, and that point we will use to generate the DM, that is the digital elevation model. So we will collect in a time mode. We will put the R parameter in time, and in every 5 seconds we will collect, we will move our rover, and in every 5 seconds it will collect the data in automatic mode, and that point we will use to create the digital elevation model. With the we will import that data in the QGIS, the software which we have learned in our previous lectures or lab. So that software we will use, and on that software we will show you that how you can use this high accurate elevation data to create the DM for any respective area. So we will first go to the auto mode, and then through the function option, this steps I already mentioned you. So I am just changing the time mode, and then in log time is 5 seconds. So when I click it, place this as a 5 second, and I will just change this point. So now it is set, and we will click on the start option, and it will start acquiring data in every 5 seconds. You can see over here it is on auto mode, and we have assigned the time mode, and the time is given for 5 seconds. So in every 5 seconds it will collect the data. So we will map this area with this time mode, and all the information or all the point which we are going to collect, that point will associate a highly accurate elevation data. So that elevation data we will use to generate the DEM. So we will press start, and now you can move in any direction, or you can simply collect the data. So we have collected few points here on the map option. You can see these are the all points. This point ID you can see over your map. So this point we will use to generate the digital elevation model. So this data we will import on the QGIS platform, and with this some QGIS plugins we will show you that how we can use this elevation data to generate the DEM. So in coming labs we will also show you, so we will give a demonstration that how you can use this data to generate the DEM on the QGIS platform. So here you can see all the point information which we have collected in our survey. So this point you can export from the job and data option. From the job and data option, here you can see the one option has been given, the export and copy data. From the export and copy data, some format has been given over here. You can choose the any of this format, but the best format is the export ASCII data, because this ASCII file or the ASCII format you can open in Excel file, or in this file you can also open on the GIS software. So you can while going to this you have to choose the data, and then to export the data, first you have to connect some USB or some external device with your controller. So some ports are given over here. So here you can see some the USB port has been given. So with this port you can directly place your pen drive over here, or you can connect the USB cable, and with this port you would be able to export your data from the file, from this system. So with this export file, so once you exported your data, so this data you can open in any of Excel file text format, or you can also import this data on the GIS platform. So in our coming lab, we will show you that how using this elevation data, how we can generate the digital elevation model. So with the using with the QGIS plugins, so we will give a demonstration to generation of DM while using this elevation data. Thank you.